This is lesson 5.5, dealing with inequalities in one triangle. All right, the positions of the longest and the shortest sides of a triangle are related to the positions of the largest and smallest angle. If in a triangle, the largest angle is across from the opposite longest side, and in a triangle, the longer side is opposite the biggest angle, so vice versa. So you can always figure out, if you know how big the angles are, how big the sides are. Biggest angle across from biggest side, smallest angle across from smallest side. So write the angles in order from smallest to largest. Well, 17.2 is the smallest side. So F is opposite. So angle F would be smallest. Angle H would be next. Angle G would be the biggest. Write the sides in order from shortest to longest. Well, if this is 22 and that's 90, whoops. Okay, sorry about this. If this is 22 and that's 90, this has to be what, 68? So the shortest side would be across from 22, which is EF. Middle side would be DF. Longest side would be the hypotenuse. Across from 90 would be DE. All right. Okay. A certain relationship must exist among the lengths of three segments in order for them to form a triangle. Meaning, the sum of any two sides lengths of a triangle is greater than the third side length. So AB plus BC is greater than AC. BC plus AC greater than AB. AC plus AB greater than BC. So tell whether the triangle can have sides with the given lengths. Explain. Well, you put them in order. 7, 10, 19. If you put them in order, you just got to do it once. Well, what's 7 plus 10? 17. 17 is not bigger than 19, so this cannot form a triangle. Those side lengths cannot form a triangle. Put them in order. They are 2 plus 3 plus 3.1 is 5.4. That is bigger than 4.6, so that can form a triangle. All right, plug these in here. 4 plus 6 is 10. N squared 6 is 15. And 4 is 12, so we want to put those in order. 10, 12, 15. 10 plus 12 is 22, bigger than 15. So yes, those could form a triangle. Okay. All right. The lengths of two sides of a triangle are 8 and 13. Find the range of the possible lengths of the third side. All right, so you're going to set up your three inequalities. X plus 8 has to be bigger than 13. X plus 13 has to be bigger than than 8. And 8 plus 13 has to be greater than x. Then you solve, so we would subtract 8 to give me x is greater than 5. Subtract 13 to give me x is greater than negative 5. This becomes 21, so turn it around then. 21 is greater than x is the same thing as x is less than 21. So x is greater than 5 and x is greater than negative 5. Well, if you're bigger than 5, you have to be bigger than negative 5, so that is going to get rid of that. And then, so your answers are going to be between 5 and 21, greater than 5, but less than 21. Usually going to end up pitching one of your answers because you won't need it. All right, let's try that again. The lengths of three sides of a triangle are 2n plus 1, 5, and 8. All right, find the range of possible values. 2n plus 1 plus 5 is greater than 8. 2n plus 1 plus 8 is greater than 5. And 8 plus 5 is greater than 2n plus 1. So that becomes 6. Subtract 6. So n is greater than 1 for the top one. That is 9. Subtract 9. So 2n is greater than negative 4. So n is greater than negative 2. This becomes 13. Then it becomes 12. divide by 2. So 6 is greater than n, or n is less than 6. Well, if n is greater than 1, it already has to be greater than -2. So we're going to get rid of that. So our two answers are n is greater than 1, but n is less than 6. So that is our range. So set up your three inequalities, solve them, and go from there.